morning, students. Today we are going to have this one, motion in a straight line. Okay, these are very simple topics. To understand those things, we have to understand basic concepts of differentiation and integration. That is calculus. We see differentiation and integration today. Okay, the remaining topics are a little bit easy, and if you know all these things right from 8th to 9th class. Okay, that is velocity of a body along a straight line. Okay, first we see this concept. We have to apply the calculus to this one. Then what is this? What is the importance of that one and how to do that? Okay, differentiation. If we are having a function means it is some parameter which is going to change with reference to other parameter. That is what we call it as function. Okay. Here we take y as a function of x. That is, if we change the value of x, the y is going to be changed. And we just take as an example a curve like this. In this one, we take a point of observation as p. Then, what is the change of the function at p? Exact change of a function at p. To understand that one, see, y is a function of x. If we change the value of x, y is going to be changed. Okay. That is, to understand the change of value of y at p, we take some value for x, an increment of x plus delta x. Okay. Then we go to this one, a point q, which is having x plus delta x. Then at that value of delta x plus delta x, the value of y is y plus delta y. Okay. Now you see, we are concerned with the change of the function at point p. To understand that one, we have to take a point away from this p. Then, if you calculate the value, generally we write that one as tan theta. This is delta y by delta x. That is, or simply in our notation, y2 minus y1 by x2 minus x1, or y plus delta y minus y by x plus delta x minus x, or y plus delta y minus y divided by delta x. Okay, that is changing the value of y with respect to changing the value of x. But the situation is we have to concentrate at p. Then if we move this q towards p, then we are going to get an exact value when q coincides with p. Q coincides with p. Then our delta x becomes 0. Okay. Now we take that one as slope here. Limit delta y by delta x as delta x tends to 0. Delta x tends to 0 but not 0. You have to understand that logic here. It is tending towards 0. It is so small that we can treat that one as 0, but it is not 0. That is, it is not 0 means we should take a point just immediate to that one, so that it is very close to the point P, where we can consider or we can treat the difference between those two points as nothing, that is 0. Okay. It is tending towards 0 but not 0. It is so small that we can treat that one as a 0. That is the concept of limit here. Limit means we are limiting that one. We are limiting that one. That is, we are limiting this one at p. We are limiting that one at p. The meaning of that one, it is so close to p that there is no difference between those two points. But there is a difference. Okay. That's why we won't write it as delta x is equal to 0, tending towards 0. It is so small that it is equal to 0, but not 0. Okay, that should be very important. We call this type of concept as, or delta y, as differential of y with respect to x, dy by dx. Dy by dx. That is, in our sense, it gives exact value at t. Exact value at t. Exact change of value of y with respect to change of value of x at t. That is the meaning. exact change of value of y with respect to exact change of value of x at t. That is the meaning of this one. Limit delta by delta x as delta x tends to 0. Okay. And if we take our applications, the differential of position or displacement is called as velocity with respect to time. With respect to time. In the same way, the differential of velocity is called as acceleration. Always we take this one as time. Time rate of displacement. Time rate of velocity is acceleration. Time rate of velocity is acceleration. Time rate of position is velocity. Time rate of velocity is acceleration. Okay. That is, the concept is we are concerned with the exact change at a particular position. That is, at a particular position, what is the change that is going to take place or that is taking place is called as differentiation. We are concentrating about at a point, okay, about a point or at a point, okay. That is the meaning of this exact one at a particular point, okay. It is called as differentiation. Treating these mathematical concepts at those points is called as differentiation, okay. Now we understand integration. Integration means integrate. That is addition. Okay. That is, it is a continuous addition or multiplication. There differentiation is we are dividing delta y by delta x. That is the case of sorting off into a small thing. This is gathering into a large one. That is called as integration. Okay. Integrate means we are going to add. Then, how to add these values? Like from the point of this function. If we are having a function f of x on this y-axis and x on this one. Suppose if we are having a strip like this, then we can find the area by this one into this one. The meaning of that one is we are having this type of lines. Okay, vertical lines from A to B, and if you take that one, we are going to get the area. That is, if we are having vertical lines from A to B, all those lines they are going to sum up as a area. That area is given by this one into this one. Okay. Then we apply this type of concept for a continuous change of function like this. Okay. This is a function f of x. Okay. Now it is continuously changing. Now, if we divide this function into small elements or small steps, then at a particular value, see here, that is, we are going to divide this one into n number of steps, small steps, so that for a given step, the width is going to be a constant. That is, we are dividing this one into so many small things that each part is having a constant value. Okay, that is the concept. Then we call this one as x I minus 1 strip, and the difference is this is xi. This is xi and this is xi minus 1. The strip between xi minus 1 and xi we are considering. Then the area of strip is written as f of xi. That is the value at xi into this one, change of this one, f of xi into delta x. Therefore, the total area means we have to sum up all these I elements from 1 to n, from 1 to n or 0 to n. Okay, from 0 to n. X is 0. Okay, x is 0. Okay, generally we probably write that one as 1. That is first element. Okay, even though we show that one as x, from x0 to 1, we write this one as 1. That we have 1 to 2, or sometimes in the case of addition, x0 to 0 to n also. Okay, from that is first element to nth element. F of xi into delta x. Delta a is 0. Okay, we write that value like this. F of xi to delta. It is so small. If it is, that is here, you have to remember that if this n tends to infinity, n tends to infinity, is so large that we can write this one as dx. Infinitesimally small. Infinitesimally small. This is called as infinitesimally small. Infinitesimally small means it is so small that we are going to take the limit as almost all 0. That is tending towards 0. Okay. Infinitesimally small. Then we write a as integration. That is, we have to integrate all these bits from a to b. From a to b. It is written as integral of a to b f of x dx. Okay. Or what we are doing here is we are summing all the elements. We are summing all the elements. Okay. Integration. Okay. Or generally we find areas. We are just multiplying. As I told you, if you take this line, some number of lines are there. If we multiply those things, we are going to get area. It gives the area with x-axis. Okay. Integration is summation. The differentiation is we are sorting out to a smaller quantity. These are reverse process. That is, if a differential of g of x is f of x, then we can simply write g of x is equal to f of x dx integral. Okay. This is the as a sum as a whole. This is as a point. At a point. Okay. You have to remember these two concepts. Okay. And we apply these type of concepts, these two concepts, integration and differentiation, in our physical problems or in our day-to-day examples at so many places. Okay. And also, I think, considering this motion in a straight line, okay, you know what is velocity, speed, displacement, distance, and acceleration. We are having only uniform acceleration along a straight line. Okay, and I think we know all those basic formulas. V is equal to V naught square plus V square is equal to V naught square plus 2as. V is equal to V naught plus AT, like that, and x is equal to V naught t plus half a t square. All these formulas, it is very simple to have derivations for those things. I think you are having those derivations right from the 8th class. You just try to understand them. Okay.